Let's look to problem number 2, because I did not talk. I promised you last time I need you to struggle with it. But he said it is 8 feet layer beneath a building is overlaid by a stratum of permeable sand and the gravel and is underlined by impermeable bedrock. Impermeable bedrock. That's he's saying that we have a layer of 8 feet beneath a building. Here we have sand and the gravel. And here, bedrock. Bedrock is the best soil, by the way, can support a structure. Rocks and bedrocks, or probably I told you a story about this building in San Francisco. I don't know if you searched it or not, because they forgot or they did not complete the geotechnical report. So the building started to lean, okay? I don't know if I told you. I believe I told this probably the seismic group. There was a segment on 60 Minutes, by the way. This is not my story. 60 Minutes, a high-rise building, okay, very expensive apartments or condominium, whatever you'd like to call it. I think 110 stories, and they found that the building, okay, it is supported by piles, okay, but the geotechnical report was a little bit short, and the piles did not rest on the bedrock like this. So the piles, okay, were hanging like that. This is the rock layer here, and unfortunately, the piles didn't go all the way to here. So the building is start to lean right now. It's starting, okay, and it was in 60 minutes. If you search it in 60 minutes, the leaning, okay, buildings in San Francisco, you will get it very easily. So the building start to do this. And when they showed us on 60 minutes, they have a steel ball or something. Okay, they put it at one end of the room, and the ball is running to the other direction, because and it is going to cost them to fix it $100 million to fix this problem. They start to drive additional piles, and in order to fix it, according to the structural engineer, is in charge $100 million just to fix this problem. Hopefully they can catch it, okay, before the building is leaning, okay, leaning more and more. So geotechnical report is a serious geotechnical report, and I'm going to talk about that, by the way. There is one section we're going to talk about geotechnical report. Is very important, okay, to know exactly the site where you are going to build this building. The profile of the soil. They go and they drill and take samples all the way until they see what is the profile. What kind of soil is that? Sand, clay, okay? What type of, what is the water content? What is the specific gravity? What is the unit weight? Where is the hard rock? And all these things, because your building will rely on the supporting soil. If the soil is weak, okay, the building was going to be a problem. So this is a side story. If you like to search it on 60 Minutes, you are very welcome to do that. And he said that the total expected primary consolidation settlement of the clay layer due to footing load is 2.5 inches. The total consolidation, 2.5 inches. The coefficient of consolidation, C sub V. So the equation that I wrote, by the way, or you see in the book, T sub V is equal C sub V times T over H dr square. This is the equation in book number 3. Don't forget this equation. Here it is. T sub V is equal C sub V T over H dr, which is equation 3-19. Okay, just in case, I'm not expecting this for the AM, but somebody or one of you last semester, one engineer told me that they ask a little bit about consolidation. Can you go in depth? I told them, yeah, I will go and bring more problems, but this for a geotechnical afternoon is a very good experience. Okay, so the question is, the C sub V, the coefficient of consolidation, they already determined. This is inches square per minute. Units are very important, because there's a typo here, by the way. I said millimeter and inches. Units are very, very important, and I will correct my typo in just a minute. The amount of a primary consolidation settlement in inches that will occur in 1 year is most nearly. So the whole thing, it will happen, everything will take how many years? We can see that. But let us see how can we use the chart I was telling you about. So T sub V is equal C sub V times time times or divided by HDR square. So let us get T sub V calculated. C sub V is given 2.68 times 10 to the negative 3. This is what? Inches square per minute. They determine this in the lab. Don't worry. This will be given to you. Times T. I will say the T, he would like to know how much consolidation will occur in 1 year. So it is 1 year. Do you remember HDR? This is a single or double drain? Single. So what is the HDR? It is 8. According to this chart. Do you remember this chart? Here it is. This is the thickness of the layer. If it's a single is.
Doctor, how do you knew that it was a single?
Because he said that the 8 feet layer of clay, okay, overlaid by a sand and the gravel on the top and underlined, okay, underlain by impermeable rock. So the water cannot go through the rock. Impermeable means that a rock layer will prevent the water from going through. So the only way that the water can drain is, run away is one way, single, okay, one way. If it is drained at both sides, we call it double. And in this case, this will be 2 HDR. So right now, and I'll put this 8 feet. And you say, oh, square it. You can see here, this is unbalanced equation. Why? I have feet. I have inches square. I have minute. And I have years. Oh my God, this is mixing banana and the oranges. And no, we need to be the same, okay, units. So the 8 feet, it must be inches. So before I multiply it or I square it, I will convert the 8 feet into the famous, let me get something here to correct my, okay, but I wrote it intentionally at least to show you that units are extremely important in every problem, and in this specific problem, the one we're talking about here, you will find that the 8 feet must be multiplied by 12 to get it 96, and I will do this immediately to correct my mistake. Here it is. So seems to me I ran out of this. Here we go. Okay. So it is 8 feet times 12 inches per foot, and this is square. So I guarantee that this is inch square and this inch square. What about minute and year? In this case, I need to convert. Okay. So convert the year into minute. So I will say times, and forgive me, times. I will put here 60 minutes in 1 hour times 24 hours per a day. And if you like to use a 365.25 days, okay, per year. All this must be multiplied by this. Can you read my So after we finish the units, let us cancel it out. Inch square will cancel with inch square. Feet will cancel with 8 feet, with the feet. 1 year, it cancel with the year. And the minute will cancel with minute. An hour will cancel with hour. And a day will cancel with day. So what you are going to get for T sub V is what? What you are going to get T sub V, which is a time factor. You will get this as a percentage. Can you do this calculation and tell me what is the fraction or the percentage, whatever it is? Point what? Okay. 0.152. Okay. Everybody got the same answer, or I got something different? Everybody, can you double check with me with this number, please? Okay. So this is the T sub V time factor as a percentage. In this equation, it will come as a percentage. So what is next? The next is to go to this table. Go ahead, sorry.
Oh, no, I was talking about.
What is next? So they came up with this table for us. Okay. They have two tables here. We have T sub V, and from T sub V, we can get what is the U percent. So 0.152, this will give us how much the U, which is a time factor, the percentage of the consolidation. So the time factor is calculated as 0.12, and this is representing a percentage of how much consolidation will take as a percentage of the entire 2.5 feet. So I will go to this table. Let us remove this percent, at least will not confuse you for the time being. So 0.152. I will go to this table and I will look for a TV of 0.152. 0.152 is giving you what? What is the U percent? 44. That means that the amount of consolidation in inches would occur over 1 year. So the consolidation after 1 year is equal to the U as a percentage times how much is the total? 2.5 inches. Thank you. So they are saying that we are expecting that this, the total expected, the word expected is very important. Consolidation, the layer will go down all the way. Based on what? they took a sample of this clay layer, by the way, and they go to the lab and they do consolidation curve. It's not just based on something, because there are different types of clay layers. And it's not 100% clay. It could be clay and silt and the clay and sand and so on. We have different types, and we are going to see this in chapter 7. So they do samples, okay, from this is why the geotechnical report, they take a sample from all the types of soil that encountered at this location. So if I know that this is 44%, this will give me U percent is equal 44%. So I will take this and plug it here. 44% of the 2.5 inches will give you what? 1.1 inches, rounding. And what is the best answer here? A as an apple.